Welcome to the how-to for the mole in molar mass. When we talk about the mole, chemists use the mole as a counting unit for the number of atoms, ions, or molecules in a sample. And when we talk about the 1 mole of objects contains the same number of objects as there are atoms in exactly 12 grams of carbon. And so really 1 mole then is equal to 6.022 times 10 to the 23rd of that object. We call this Avogadro's number. I like to think of it as a dozen of donuts. We know that a dozen donuts is equal to 12 donuts. When we talk about 1 mole of donuts, we would know that's equal to 6.022 times 10 to the 23rd donuts. So the mole is really just the SI base unit for the amount of a substance. And whenever we talk about a mole, it's always going to be the same number. So when we say how many carbon atoms are in 1 mole, well, what does that mean? It means that we're going to have 6.022 times 10 to the 23rd carbon atoms, because that's what we're counting. How many elephants are in 1 mole? Well, 6.022 times 10 to the 23rd elephants. And if we wanted to know how many dollar bills are in 1 mole, again, it's 6.022 times 10 to the 23rd dollar bills. So it's a counting unit. And so if we were to use this and understand that when we talk about the atomic weight of an element, we know that this is in atomic mass units. And if I asked you what was the atomic mass of chlorine, a single chlorine atom, you would look at chlorine on the periodic table. You would look at the number below it, which is 35.5 atomic mass units. When we talk about molar mass, it's the exact same calculation. The only difference is the units. Because in molar mass, we're talking about the amount of grams per mole. So we end up with 35.5 grams in 1 mole of chlorine. This is our molar mass. It tells us how many grams are in 1 mole of that substance. So again, we understand that chlorine has an atomic weight of 35.5 atomic mass units, but it has 35.5 grams in 1 mole of chlorine. Well, we could also use this and write it slightly differently, where 1 mole of chlorine has 35.5 grams. And we're going to see that these two conversion units are important when we look at dimensional analysis. Lastly, when we calculate molar mass, we're really just thinking about the total. So if we were talking about 1 mole of oxygen gas, that really means that we have 2 oxygen atoms, where each one would have a mass of 16.0 grams, and so we get a total of 32.0 grams per mole of O2. We could do the same thing for H2O, where we know that we have 2 hydrogens, each worth 1.0 grams, plus we have a single oxygen, which is 16.0 grams, and so again we get 18.0 grams per mole of H2O. We could do the same thing for sodium chloride. One last thing that's important is understanding the name of the substance. Atomic nitrogen. Atomic nitrogen just means we have a single atom of nitrogen. That means it has a formula weight of 14.0 atomic mass units. Well, if we were talking about its molar mass, then it's just 14.0 grams per mole. That means that we would have a total of 6.02 times 10 to the 23rd nitrogen atoms, right? Because we're talking about a single atom of nitrogen. However, if we're talking about molecular nitrogen, which means it has a formula of N2, nitrogen gas, its formula weight would then be 2 times 14.0 atomic mass units, so we get 28. Same thing when we talk about the molar mass. It would be 28 grams per mole. If we were to ask how many molecules of nitrogen we have in 1 mole of nitrogen gas, that's 6.02 times 10 to the 23rd nitrogen gas molecules. But if we were to ask how many nitrogen atoms, well, we have 2 nitrogen atoms in every molecule. So we're going to have twice as many when we talk about the nitrogen atoms in that molecule. So we have 2 times Avogadro's number. Same thing when we talk about silver ions, right? The formula is going to be almost the same except for the charge. Formula weight is identical. The molar mass is identical. And then we talk about how many number and kind of particles. Well, here we have 6.02 times 10 to the 23rd silver atoms. Down here we have silver ions. And then we can break this down further when we look at ionic compounds. That concludes how to understand what the mole and molar mass.